Today we're shooting the Barnes 129 grain LRX out of a 270 Winchester. I want to thank Clear Ballistics for providing me with the synthetic gelatin blocks. If you watched my previous videos, you'll know what happened there. And then I want to also thank the technicians at Barnes for providing me with the reduced velocity load data specifically for this testing. The data that I'm using is from Barnes. It is reduced velocity just for this testing, so I will not be releasing that data. Please keep in mind what's most important is not that I'm shooting it out of a 270 Winchester or the distances that I am shooting at. What's most important is the impact velocity of these tests. We're going to shoot 2 high velocity impacts at the synthetic gelatin. Then we're going to shoot a low velocity into the synthetic gelatin. Then we're going to shoot another high velocity at the Knox gelatin. After we finish our shooting, we're going to go ahead and head to the reloading bench, and we're going to analyze that velocity with the JBM Ballistics chart. Timestamps are in the description. Let's go ahead and get to testing. Impact velocity was 2,993. The bullet entered around ½ inch, expanded, and then veered off to the side and exited the second block. Let's go ahead and take a quick look. Okay, this is a 16-inch block. Again, we lost the bullet from the shot. And I'll go ahead and rotate the block in order for you to get a better look at it. We got expansion about ½ inch into the block, which was good. We have a temporary stretch cavity of, say, approximately, I'll give it 8.5 inches, and then it started tapering down. We have a bullet fragment here over at about the 13, well, about 12.5 inch mark. There's going to be a bullet fragment there. And then actually you could see the bullet started to veer off right around that 10.5 inch mark. And I'm going to guess that the reason why it started veering off was because we have a piece of that bullet that had splintered off. And then there's going to be another bullet fragment that's actually in the second block as well. That's pretty, I've seen that happen before with Barnes bullets. This was a pretty high impact velocity shot for a long range bullet, so that could be understandable. But we're going to go ahead and duplicate this shot again. Impact velocity was 2,947. Remember, this simulates a 100-yard shot. The bullet again entered the block, expanded, shed a pedal, and then veered off to the side. Let's go ahead and take a look. Okay, please remember that these are 16-inch blocks. Again, this top track is the track that we're going to be following here. It entered in ½ an inch, started its expansion like the last shot that we made. We have a large temporary stretch cavity of about 9.5 inches. That's really good. I like to see that. That cavity, by the way, that's looking to be around, I'd say probably around 2 inches wide at its widest point. And then it'll start to come down narrow. It'll start to narrow in at that 9.5 inches. It starts narrowing. And the bullet veered off. Again, we could see where one of the petals did shed, and it's sitting here on the side where it did shed out, and this is coming off of right where it started to veer. So that Barnes nose is peeling back, and then it's shedding its petal. Here's a couple of other petals from the last shot, and then actually we've got another petal from this shot in this block in the back here. Hold on. Okay, so here's the petal. Again, this was from this second shot as well. So we had 2 petals shed from this second shot. We had 2 petals shed from the last shot. And both of the shots veered off to the side. I was unable to capture either bullet. This is frustrating for me as a tester. It happens frequently when I test Barnes. Again, this track right here is going to be the last shot that we just did. Let's go ahead, and what I did was I loaded a load even slower. This is not the low velocity load that we're going to shoot next. Next, what we're going to do is we're going to shoot one that's just slightly slower. Maybe it'll simulate a 150-yard shot or so. So let's go ahead and test that one and see if hopefully we can capture a bullet. Okay, impact velocity was 2,862. Again, we did have the same results. We had some penetration into about 1/2 inch, and then there was expansion. The bullet veered off to the side. I thought we were going to lose it, but we did actually capture it in the back block there. So penetration can only be estimated. I can give this an estimated 32 inches of penetration, but I can't say that for sure because the bullet's not tracking straight. And out of 3 shots, so far it has not tracked straight. So let's go ahead and take a look at the blocks. Okay, so again, we had the impact velocity as 2,862. We entered about 1/2 inch into the block. We do have some expansion, that temporary wound cavity, if you will. It expanded probably to about, at its largest point, let me just check on the side. Yeah, at its largest point, it's going to be about 1.25 inches. It happened about inch in expansion, and then proceeded to about 9.5, 10 inches where it started coming down. We do have this right in here where there's actually a pedal that had shed. So we've got a pedal shed right here. I'll pull that out. There's one, and then there's actually another pedal that had shed right here. I'll pull that out. There's another one. I don't see any more in the further blocks. It's difficult for me to say for sure what the penetration was on this because it did have that area of emptiness between the blocks, because it did veer off to the side, but because I had that one block kind of set crossways, it was able to capture it. So it didn't, we'll say 32 inches. But this is typical of what I've seen in Barnes. And here's that bullet that we were able to capture. You could see that Barnes mushroom, and you can see where the petals had actually shed off of the bullet. Let's go ahead and shoot that low velocity test. Okay, impact velocity was 2,090. I can only estimate penetration again because the bullet did start to veer off. There was an empty space, but I could say an estimated 32 inches once more. It penetrated to the same depth as the last bullet that we had shot. It did enter into that third block over there. Let's go ahead and take a look. Okay, again, impact velocity was 2,090. You're gonna see there's this large track here. This is actually a combination of 2 tracks. I can see it probably better than you can see on the camera, but there's a much smaller track to the side of the larger track from our earlier shot. So that much smaller track is going to be that 2,090. What I see is that it entered in about 1.5 inches, inch and a half to 1.75 inches, and then it started its expansion. And we have a stretch cavity that went to about 9.5 inches. Now remember, it didn't start its expansion until about 1.25 inches, 1.5 inches. So this was our stretch cavity, whereas in the previous shots, this was our stretch cavity. So if that means anything to you guys. And then it did start to come into a caliber-sized hole, and then it did veer off again. So I'm going to go ahead and show you the veer so you can see. I mean, it's really visible how much of a curve happened in these blocks. All right, I've turned the mic around. You can take a look. You could see that actually how much of a curve was in that track.
it's this top track right here, and you can see it just for no reason just starts curving off to the side. This is actually the bullet that I recovered. I've got one more shot promised to you guys. It's going to be into that Knox gelatin, so let's go ahead and test that.
I am very happy. We have actually captured the bullet, so we have good penetration data. The impact velocity was 2,954. Penetration, 25.5 inches. What I did was I took those two Clear Ballistics blocks, I butted them together so that if that bullet started to veer off again, then at least one of those blocks would be able to capture it. Let's go ahead and take a look. Okay, remember that impact velocity was 2,954. Here is our, what we're looking at is we're looking at our temporary wound tract. So this will be not just our permanent wound tract. The Knox blocks, the organic gelatin is really good for showing that temporary stretch. On this shot, we entered about 1/2 inch is when we started having that expansion, as in the previous shots. And then we have that temporary wound cavity. You can see here going in. That's about an inch, about 1.5 inches, 1 inch to 1.5 inches in that temporary wound cavity. And then what we have here is expansion 1/2 inch, temporary wound cavity that going until about 9.5 inches or so, and then it starts closing up again. And then we were able to capture the bullet. So then we do have the bullet over here sitting at 25.5 inches. Let's go ahead and take a look at that. Ooh, nicely wedged. It actually did track straight as opposed to the previous shots where it had veered. This one actually tracked straight. Now you can see the petals actually came back, and that's a beautiful mushroom right there. I'm actually pretty surprised. And we're back at the bench. Well, I probably should have suspected the results that we got today. I've tested a lot of Barnes bullets in the past, never these LRX, but I've tested a lot of Barnes bullets in the past personally, and I've always seen them veer off. I've very rarely seen a bullet track straight from Barnes. I'm not sure why, possibly something to do with how it opens up. Some people think that a bullet not tracking straight is a good thing. I don't believe it's a good thing, because I want to be able to look I want to know where that bullet's traveling to when I shoot the animal. So sometimes if you have like a quartering away or a quartering two shot, you visualize where that bullet's going to go within the animal as it's doing a cross section. And if that bullet's not tracking straight, I can't trust that it's going to do what I want it to do. I can't trust that it's going to impact the area of the animal that I want it to impact. But anyway, we have the chart here from JBM Ballistics. The muzzle velocity that I've used is 3,140 feet per second. That is the manufacturer's advertised muzzle velocity, and I believe that is a very achievable number with these copper bullets. I'm able to get that number quite easily out of my 22.5 inch barrel. The shots that we took today are going to simulate a 75 to 125 yard shot. Even though you go long range hunting, guarantee there is that chance that an animal will always poke out between 75 and 125. I've got a area that I can easily take a 450 yard shot, but I did have something pop out at 75 yards over there, and it just happens. We don't control, so we need to make sure that long range bullet also is effective at shorter ranges, and that's what we did today. I have a 250 yard zero on my rifle. Your zero may be different. At 250 yards, we're going 2,625 feet per second. What I'm more concerned with is going to be that windage. So windage here is 4 inches. If you're assuming a 4-inch radius on that kill zone, which makes it an 8-inch pie, then I think that 250 yard shot, if you're in a gusty winds,
that 250 yard shot is going to be your maximum. Of course, the winds are not always blowing that hard, so the bullet could in fact impact where it needs to. Then that lower velocity shot that we took today is going to simulate that 525 to 550 yard. That's that one that was at 2,090 feet per second. So that's going to simulate that 225 to 250. Remember, this is a long range bullet, and that's what it was designed to do. So this is that 2,090 feet per second bullet. You can see the nose just kind of peeled back ever so slightly. I'll show you in the camera. It's very pretty the way that these bullets peel back. I'm not really an advocate for the bullets, the copper bullets that stay together like this. I like them to be a little bit more dramatic, but I know that a lot of people kill a lot of game, and they use these bullets pretty effectively. It's essentially as long as you put it where it belongs. And then that gets back to my veering, so if you put the bullet where it belongs and then the bullet inside the animal veers off, then and it's not expanding to the point where it's causing a lot of shedding of the nose and a lot of internal damage, then how do you know what you're hitting? So I have really mixed feelings about this, but you may like it, you may have really good experience with it, and that's going to be your responsibility to make a sound decision. Keep in mind that these are LRX bullets. These are going to be a really good ballistic coefficient. The ballistic coefficient of the Barnes LRX is 0.463 for 130 grain 270. That's pretty good. That's pretty good ballistic coefficient. But remember this, ballistic coefficients, I think that lately we're kind of dying at the altar of ballistic coefficients, which is not a terrible thing, but also keep in mind how much it actually buys you. So this is your 500 yard shot, and your ballistic coefficient at 500 yards is getting you 17.5 inches of wind drift. Now, if we look at that Lehigh Defense controlled chaos, you're only getting, not even an inch difference of wind drift at that distance. So an inch is going to be this much. So just kind of keep in mind that ballistic coefficient is not going to save you if you're in a really heavy crosswind. Your bullet is going to blow around regardless. It just buys you a little bit. It buys you a little bit. And sometimes that little bit really does matter, but I would be more concerned about accuracy, that precision of that bullet, and the terminal ballistics of that bullet. So if it buys me this much but the terminal ballistics is not very good, then I want to start looking a little bit elsewhere. So here's the let's go ahead and look at the bullets that we had been able to recover. Again, I've had tested a lot of Barnes bullets in the past. I never did the LRX before, but I've always had them veer off on me. So I should have expected that. I wasn't quite sure what to expect in the new LRX line, but here's what I've gotten. So this is that 2,090 feet per second bullet. You can see the expansion at the smallest point is 0.397. At its widest point, it's 0.458. Put that over there. So this is the one that was impacted at 2,862 feet per second. We did have actually some of the petals coming off, and we saw that quite a lot in the testing today. So the expansion was 0.449 and 0.527. And here's actually some of the petals from that Lehigh Defense that came off. They're very similar in size to the petals that came from the hammer bullet, except the hammer bullet was designed for this to happen. So, and when the hammer bullet sheds its nose, it's very dramatic. It was designed to shed its nose, and it happens where it needs to. These petals didn't come off until after the 9-inch mark, which would be past a usable vital zone. Now, also, mind you, the size of the petals, you didn't get a whole lot of them. So each shot maybe had like 2 petals that came off. But look at the size difference between the Lehigh Defense petals and the Barnes petals. And then once again, the Lehigh Defense bullet was designed to shed its nose, just like the hammer bullet was designed to shed its nose. So the air temperature today was 37 degrees Fahrenheit. The stability factor of these bullets was actually really good. So we're at 0.1487 at the high velocity ones. And then I did this low velocity stability factor just to tell you guys that it was still within a good margin when I was doing those low velocity tests. The penetrations, we were estimating the penetration to be 32 inches, but now that we did actually capture a bullet at 25.5, I believe that penetration would have been a lot less than 32 inches, but probably not too much less, maybe 27 to 29 inches. Still a lot of penetration that's going to go through and through most game. So that's the 129 grain Barnes LRX. This has been a comprehensive test. I'm not against testing this bullet again. Again, I want to thank Barnes. I really think that they're a wonderful company. I haven't had any bad interaction with Barnes, and I really do appreciate their help and support. I believe that they have a different philosophy when it comes to copper bullets. Barnes really pioneered these copper bullets, and then you had companies like Nosler and Hornady picking up on the same philosophy that Barnes uses for their bullets. So I really think that there's a lot of credit that needs to go to Barnes. I would like to see some more consistency on some things with Barnes. Really, I think that Barnes should look at coming out with a bullet that does shed its nose. I know that they really like their pedals, but I think that they can create some more terminal performance by shedding the front nose. So thanks for watching, guys. If you could, please go ahead and hit the subscribe button. I'm gonna have a lot more testing coming out. Please like the video and comment below. I'd like to see your comments because I really want to know more of what you're thinking. If you could, go ahead and read my pinned comment. I'm going to mention a couple of other bullets to test in the future, and I'd like to know what you guys want to see.